Today we're having a look at the newly released Alpha Flight Controls LITE from Honeycomb Aeronautical. So you're probably aware that around 6 years ago now Honeycomb introduced the Alpha Flight Controls, which is basically a yoke with a switch panel integrated into the front. So Honeycomb's vision in doing that was to shake up the entry-level end of the flight controller, or certainly the yoke controller market, not by undercutting the price at the entry level, but by delivering a technically superior product at around the same price, or comparable price to the competition. And by and large they were successful in doing that. So 6 years on, they've expanded their product line and also delivered very successfully the Bravo throttle quad and finally the Charlie rudder pedals. Now there have been a lot of ups and downs along the way. Honeycomb has had its problems, it's fair to say, with its supply chain. There have also been internal conflicts that almost took the company down, I understand. But Honeycomb seems to have found its footing again, and it has a whole roadmap of new product lines which it's starting to deliver and promising for the relatively near future. Now, case in point, one of the new lines is what they call in the LITE controls line, and the first of those to be brought to the market is this one, which is the Honeycomb Alpha LITE. Now, what is it? Or more to the point, why is it? Well, let's approach that question from two different angles. Let's first see what Honeycomb says it is and then we'll look at what it appears to be when it lands on your desk. I mean, by and large, Honeycomb market this as a stripped down version of the Alpha flight control yoke. So essentially the story goes, this is pretty much the Alpha flight control yoke without the switch panel. Now it does confusingly on the packaging say Alpha flight controls on switch panel, but there is no switch panel. It's got switches on the handle but nothing on the front fascia. The front fascia is different, but they say it's a slimmed down version, essentials only, which really means it's a 2-axis joystick at heart with a few buttons thrown in. So the story goes, it's the same device as the Alpha yoke internally, but without the frills. Now we're going to think about that in a bit more detail as we go. I have to say, I've not found anywhere that Honeycomb has exactly said that the internals of this yoke are the same as the Alpha yoke. They have hinted at it very strongly. There was a round of press events in London last month, August 2025, where various commentators and journalists were invited to try the yoke. A number of those commentators have reported that the internals are identical. There's also a couple of interviews with the chief engineer of Honeycomb, Mark Kuiper, I'm not sure how you say that name, where he has strongly hinted, his rhetoric is that it's essentially the same thing. But the implication is that it's comes off the same production line as the Alpha yoke, and just the wrapping is different, you might say. And that may or may not stand up to scrutiny as we go. So what does Honeycomb say about this yoke? Well, of course, if you look at Honeycomb's website, you'll find the usual marketing kind of information. And of course, we mustn't lose sight of the fact that this is marketing material. And sometimes we need to think about whether what's emphasised in the marketing material is what's really important. Case in point, very prominent in that description is the fact that there's a solid steel shaft. I'm not sure why they make such a big deal of that. So what? Of course that promises rigidity and a bit of weight. It is a weighty product. The fact that that's a solid steel shaft is neither here nor there. That could very successfully be done with a steel tube, and indeed the fact that it's a solid steel shaft has a downside, which is that you can't run the wires for the controls on the handle through the centre of the shaft, and that necessitates this connector with the RJ45 plugs at each end to connect the yoke body to the yoke handle. That's a nice, neat looking solution, but if you track some of the criticisms that people have made of this yoke over the 6 years that it's been out on the market, that is number one criticism, the failure of those plugs, which every time you manipulate the yoke, those things get rocked in their sockets. At least at the start, in the early production runs, those sockets seemed to be quite fragile and people were losing connectivity. So anyway, this is just a clue that sometimes what the marketing people point to doesn't give you the whole story. The other thing that's prominent in the marketing material is, if you've seen the original yoke, you'll know this, full 180 degrees of travel in the roll direction. Now it's important to say that this review that I'm doing today is an update review, let's say. I'm not going to exhaustively cover everything I covered in my original Honeycomb Alpha review video, because there's going to be a lot of repetition. Whether or not this turns out to be exactly the same mechanism, a lot of what I've said about that original yoke applies to this one as well. So I would encourage you to go back and watch that and then treat this as an update. So the handle, 180 degrees of travel, lock to lock. Realism, yeah, certainly for some aircraft, many aircraft, that's a realistic proposition. As I pointed out in my original Alpha yoke review, that's not the whole story, particularly when you're using it with the Microsoft LITE sims, by which I mean FS 2024, FS 2020, FSX, probably FS9, Prepared, which again is a Microsoft sim under the covers. All of those yokes have this non-linear scaling of the aileron axis, and I showed this in some detail in my original Alpha yoke review, and I think also in my Cytex Cessna yoke review. And that has implications, because if you watch how the yoke in the virtual cockpit follows your physical yoke, you're going to see that they don't match up. You get an attenuated response close to the centre and then a much exaggerated response out towards the extremes. And of course that is, well, in my understanding, is that's a legacy of the kind of desktop joystick devices we started out with, you know, back in the 90s I suppose, which had very short travel, and so there was a need for that scaling, and there would be nothing wrong with that, except that even in the modern sims you can't turn that off. You can mitigate it because you can edit the response curves in the latest sims, but without going into too much detail, that doesn't really give you anything back. It covers up the problem. So they make a big deal of this, but it's not as simple as they say it is. What else do they say in that marketing information? Essential realism without distractions. Well, I mean, you can make a case that that's not a very strong case, I don't think, as a marketing statement. No compromise on quality, it says. I think we'll be the judge of that. There's another fairly peculiar statement in that marketing material. It's lacking advanced features. Now that, I'm not sure what that is intended to say, but I have a little bit of an inkling, which I'll get to in a minute. Now, just an interesting observation on the language of the marketing material. There is a statement that says this yoke has minimal dead zones. Now you might remember there was a lot of controversy about dead zones with the original Alpha yoke, and Honeycomb swore blind for a long time, until it was demonstrated otherwise, that there were no dead zones at all. Now of course we know now that the dead zones have a purpose, they are there, there's nothing wrong with that. But I just thought it was interesting. Maybe that reflects a difference in the marketing strategy of Honeycomb. It's worth pointing out, by the way, that Honeycomb's management, in case you didn't know this, has undergone a bit of a seismic shift in recent, well, over the past year, let's say, and that's resulted in the departure of Nicky Repenning, who was the founder of Honeycomb. I mean, we don't know the full story of what happened at Honeycomb. So, anyway. So that's what Honeycomb says about the yoke. Let's see what we can see when we take it out of the box. So we clearly have the same form factor as the original Alpha yoke. I think it's pretty much the same dimensions are quoted, at least I haven't measured them. I don't have the original Alpha yoke anymore to compare. But the first thing you notice is the box is just this rigid bare plastic. The original Alpha yoke had this soft touch coating on, which I was actually quite critical of, just in terms of longevity. You know, we weren't sure how long that was going to last. So I think, you know, the fact they've left that off is probably quite a good thing in the long term. Although, having said that, in 6 years I haven't been able to find anybody who's experienced problems with their yoke becoming sticky. So, you know, maybe I was a little bit unfair with my original concerns. But nevertheless, this is perfectly fine look and feel to it without the soft touch coating. We do get the soft touch coating still on the yoke handle, which feels great. You know, no denying that. And I suspect that this is actually, this handle, at least the shell, you know, almost certainly comes off the same production line as the Alpha yoke. Not sure about the XPC yoke. XPC, in case you don't know, is the successor to the Alpha yoke, which is, it's two things. First of all, it's Xbox compatible as well as PC compatible, but also it notably is an upgrade in the precision and presumably the longevity of the position sensors, which are Hall effect contactless in the XPC, but in the Alpha yoke and indeed in this yoke we have potentiometers. So in case you were hoping that because this is a newer product it would have contactless sensors, you're going to be disappointed. It has potentiometers, we'll get to that. So, same basic form and dimensions, no soft touch coating on the box. The grille is different, we don't have illumination. The original grille, and it's a different shape, and it's a square shape rather than a dome. No LEDs. Now the fact that there's no LEDs might, if you have a particular mindset, plant a nagging doubt about something else, which we'll get to very shortly. We've got the same mounting system, almost, which is the, well, again, on the box contents listed on the marketing material, it describes this as a dual mounting plate. Now in the original, this was a dual mounting plate in the sense that it had a sticky pad. You know, the famous sticky pad that wasn't a sticky pad, you know, micro suction pad I think it was called, was one option, and the other option was the steel G-clamps. Now in this incarnation we get the same, it's clearly the same plate because it has the release tabs for the sticky pad, but it doesn't have a sticky pad. You know, I never tried that in my yoke, and to me it was never a credible mechanism anyway. You know, just be aware you're going to have the G-clamps as the only mounting option, but they are very hefty. And you know, all credit to Honeycomb, this is a good mounting system. All you need to do is put the yoke body on there, push it back, and then there's a couple of screw, I don't know what you call these, wheels at the back that you tighten up, and that just seats it securely on the base. And there we go, it stays where you put it. Single connection on the back, it's USB-C. I'm using an angle connector here, it doesn't come with the angle connector, that's just the way I've got it mounted. I thought I would use that. Now another interesting clue here, the USB-C socket is the only thing on the back of the yoke of any significance. There's no button. There was a button on the back of the original Alpha yoke. You know, its primary purpose was to vary the brightness of the front panel LEDs, but you will also know, or you may also know, that another purpose of that button was to help you access the onboard calibration routine, which allowed you to tinker with the dead zones. Now let's just cut to the chase. The omission of that button and of the LEDs, not to mention the omission of the switch panel, leaves some questions about whether we are able to access the calibration routine at all. I suspect we're not going to be able to access that, if indeed it exists. That's another question. You know, it's almost inconceivable to me that if this device had precisely the same internals as the original Alpha yoke, which would include the onboard calibration routine, that we wouldn't be given a way to access it. You know, why would they, what would they benefit from? You know, they would have to provide a slightly different way to access it, but you know, all it would require would be one button and one LED. Other than that, the only difference would have to be how you got into that mode, because you may remember that it required you to set the front panel switches in a particular orientation. I have asked Honeycomb whether the onboard calibration routine is available, and if so, how we can access it. I haven't received a response yet. It's been a couple of days. I don't think I'm going to receive a response, but if I do receive a response, I'm predicting it's going to be a negative one. You know, I'm not going to make a big deal about that. As I said at great length in my many previous Honeycomb videos, we need the dead zones anyway. As long as your yoke doesn't come from the factory with a ridiculous, you know, 20-degree aileron dead zone or 3 inches in pitch, then there's nothing to worry about. What else to say? As I said earlier, this yoke, like the original Alpha, uses potentiometers. It doesn't have contactless sensors. One interesting difference, and again this is a clue that the internals are not the same as the Alpha. The original Alpha yoke had 8-bit A to D converters, which means that if you plug this in to your Windows control panel or to DI view, or you know, the other ways of looking at the numerical data coming out, you would see that it was an 8-bit number in each axis. So you would get 256. It could resolve 256 different positions. And so if you did the numbers, you know, that resolution translated to, for 180 degrees of travel, it can resolve 0.7 degrees, essentially. So the smallest movement it can detect is 0.7 degrees. In the pitch axis, the smallest movement it could detect was something of the order of 0.3 millimeters. So that's what an 8-bit potentiometer or 8-bit A to D converter would give you. This has 10-bit A to D converters. We can't tell if the potentiometers are the same ones or different ones. You know, they might be cheaper ones, or they might be more expensive ones. So notionally now we get something like 0.2 degrees resolution in the aileron travel, and something like something ridiculous like 0.1 millimeters in the pitch travel. Now that precision, I think, far outperforms the actual ability to manipulate, certainly the pitch axis, precisely. We'll get to that in a minute. Let's look at the handle. So the handle, as I suggested, the mouldings are probably exactly the same mouldings. The switch inserts on the two horns of the yoke are different. They look the same from a distance. We've got a hat switch here, which is, I think, an 8-way hat switch. We've got the same two push buttons, so one on the top of the yoke handle, one on the back. We've got two push buttons on the top over here, different style, this one. These two peculiar looking switch controls, these were split on the original Alpha, so there were two separate switches, and they were typically used for electric elevator trim up and down, and perhaps rudder trim on this side. And the reason they're split, in fact the split is no real loss, unless, I suppose technically you could have mapped those two different functions, but traditionally, you know, that split is a redundancy feature, I think, to guard against runaway trim conditions. So no big deal there. You know, that's a reasonable complement of buttons and switches for basics, and, you know, the addition of a hat switch for people that want to use that for changing the view or something. Something else I noticed more or less immediately when I mounted this and had a quick play with it, the pitch action is extraordinarily stiff. Now this was a criticism of the original yoke, and, you know, I pointed out in my original review there's a discrepancy between the resistance required for rotating in the aileron direction and the resistance of the pitch axis, and they were just on different scales. You know, I measured this in my original video as something of the order of 3 kilos, you know, equivalent weight, to push this all the way in or pull it all the way out. And this is a well rehearsed criticism that you'll find out there. And there was something of a split in the community between whether this was realistic or unrealistic, whether it was a good thing or a bad thing. Now I thought it was a relatively okay thing, with the exception of, you know, that discrepancy between the forces required to pitch and roll. I have to say that my immediate response to this yoke was that it was going to be a problem. Now I measured the forces again for this new yoke, and the forces required to push it all the way in or pull it all the way out are substantially greater. To pull this yoke all the way out or to push it all the way in requires at least, well, around 4 kilos rather than 3, so that's a 35-ish% increase right off the bat. I mean, we have yet to see if that translates into any noticeable difference in flying this yoke around. So just before we jump in and give this a flight test, you know, to summarise that, as far as I can tell, the significant differences here are slightly compromised switchgear, no switches on the body, substantially stiffer pitch action, and in all probability no opportunity to tinker with the dead zones should the need arise. Other than that, not much more to say. We need to get this plugged in and we'll see how it flies. So here we are checking out the flight controls in action. We're going to repeat an approach I featured in a previous video. This is the landing on top of the dam at Lake Matthews. We're in the Cessna 152. This is quite a balanced test, a relatively straightforward approach, but the one that requires accuracy and finesse in the touchdown, and that's because we've got a narrow runway and we've got a variable surface, if you like. So it's kind of a relatively intact surface but with a bit of roughness, so we're going to get thrown around a little bit on touchdown, so we need to make it as gentle as possible. So that's the brief. We're trimmed for about 70, so we're on base leg here. We're going to put down flaps 20, probably a little bit higher than we need to be, but that's okay. We've got quite a long touchdown area. Now we've got to watch the speed carefully here. We're going around about 60 knots. Probably give it a little bit of throttle to pick it up. We don't descent rate to be too high. So we're finding it easy to get lined up. The aileron action's no problem, but it's the hold off right now, which is doable, but it's kind of a strenuous effort is required to do that. So we're going to go around and do that a couple of times more. What you would have seen there, we had very little problem lining up laterally. You know, the aileron control is very light, no problem at all with that. Elevator control is the issue here. I mean, we've got, what I'm doing there is I'm rocking it around that central kind of parking position, if you like. I don't want to call it a detent, it's not really that. It's not exactly a notch, but it feels like, you know, about, I don't know, an inch or a couple of centimetres of travel, where it's definitely in some kind of, almost like a gate, before the bungees start to restrict the movements. We came in a little bit, we're going to be very long here, but that's fine. Came in a little bit too tight. And so in the flare we're going to be needing to rock it out of that parking position substantially, particularly in the rearward direction. I'm on idle now with power at 60 knots. We need to start rounding out now. So again, we're going in and out of that centre position. I mean, that's not bad, not a bad effort there. Oops, there's that rough ground. So we'll try that one more time, I think. Idle, holding it off. Drifted over a little bit there. See, we're just doing that ballooning and then porpoising. It's almost impossible to do it without getting that. Good. Okay, we're going to throw in some interference now by doing some crosswind operations. We're at Queenstown Airport just because it's got a nice long wide runway. We've got a 15 knot crosswind and we're going to see what we can see. Right, so we're going to kick it straight with the rudder, left aileron, a little bit of power. Try and bring it down onto one wheel. We're still getting that porpoising though. I mean, we've got control, but it's really hard to keep control when we're fighting that brutal pitch force. We're in the crab, power off, kicking it straight with the right rudder, left aileron, keeping the power off this time. So we've got to do more work with that elevator. Well, we kind of got it there, that wasn't too bad. So just as another experiment, we'll do a quick, very sketchy trip around the block. This is Goheen. We're not looking for finesse here, we're looking for controllability. So as I say, a very sketchy circuit. And we're doing it in the Champion Scout because it's a much nippier aircraft than any of the Cessnas. We're just going to try and fly a reasonably controlled circuit. So there's the river onto the base leg without hopefully messing our height up too much. Idle now. Right, try and hold it off a little bit better this time. credible landing, I think. So there it is, the Honeycomb Alpha Flight Controls LITE. As we've seen, it flies somewhat competently, but it's not all good news. You know, it is less satisfactory, I would say, than the original yoke, particularly that pitch action. It is just so much heavier. I mean, it does centre assertively in both directions with minimal jittering. There was an FAQ posted by Honeycomb for the original Alpha Flight Controls, and it addressed this pitch stiffness, and what it said was that the pitch stiffness was calculated to match the specific bearings that were used in the pitch axis, so that the pitch action would reliably return to centre within a tolerance of 3mm. Now presumably that means 3mm in each direction, so that would imply that that tension was calculated to allow for an imprecision of up to 6mm total around the centre point. And so you have to wonder if this increase in the pitch force is a consequence of some sort of change to the internal mechanism, and specifically whether they've used different and likely cheaper ball bearings or roller bearings, whatever they are. Now I can't confirm or deny whether they've done that. It's difficult otherwise to see where the cost savings have been made. This yoke retails currently for £170, and the original Alpha yoke is still available. That's, I think, listed at £250. So that's an £80 difference. That's a heck of a saving. It seems to me it's more of a saving than you would get from leaving off a couple of switches, the switch panels on the front, the LEDs and the soft touch coating on the box. Well, I don't know. I mean, I'm not, well versed in the manufacturing economics, but for me the combined evidence of we've clearly got different A to D converters, the fact that we don't have access probably to the calibration routine suggests that that calibration routine may not be there, and then that increase in the pitch force. Flying this around so far has been a very unsatisfactory experience. I've flown it around for a couple of days, and to some extent you do accommodate to that, the feel of that pitch action, but I think on balance it's just too much. It's too much to allow you to get the precision that you need, particularly flying it through the flare with one hand. Don't forget, we fly this yoke with one hand, but for me that brutal pitch action is pretty close to being a deal breaker. It's not just the sheer forces. There is, smoothness. There's always been what sounds and feels a little bit like a scratchy, scrapey feel. I don't think that's a big deal in its own right. It does run smooth, and it is stiction free. There is none of that stop-start. But what there is, even more so in this light version of the yoke than in the original, there is not a detent in the centre or a notch, but there is a definite, I suppose, parking zone, which the limits of which I'm demonstrating here. And you could probably do this as an experiment if you had sufficiently precise measuring equipment. If you plotted a graph of the forces required to increase the displacement, you'd probably find it was very shallow around what I've called that parking zone, and then suddenly there's a step up where you go from a few hundred grams to like a kilo or 2 kilos to get out of that. It's like a gravity well. And in practice that's what gets in the way. It's not so much that once you're out of that it requires your bicep to be doing significant duty. It's really the effort to get it in and out of that parking zone. At the end of the day, what it means is flying that, particularly through the flare, but also holding back in a turn. You can't do that with sufficient smoothness, rapidity and control that you need. So there it is. Your mileage may vary. If you're on a budget, or if you fly airliners and the finer points of controlling the aircraft through the flare aren't something you're particularly concerned about, by all means buy one of these. But if you're truly interested in the kind of flying that requires you to control the aircraft smoothly and precisely, I'm not sure I could recommend this.